Let's deal with the third graphing rational functions example this morning. Well, for me, it's this morning. Whenever you're watching it, it's whenever it is. Evaluate a function at 0 to find the y-intercepts. These are the same exact things that I've been talking about for each one of these. The only difference in this particular video, the very first one, we had vertical asymptotes. We had the graph, both ends, and the stuff in between. Then in the last example, we had removable discontinuity, otherwise known as a hole, that we had to go through and visualize. And then in this example, since we're going through all the different parts here, we're going to deal with some slant asymptotes. So here's our example here, and one of the things that we need to go through and do is to figure out, all right, what is the y-intercept? So we'll do that first. So my y-intercept is located at, all right, so I put 0 in for x's, I get -8. I put a 0 in for this x, I get 1 in the denominator, so it's located at the location of 0, -8. All right, so let's see, this is -10, so -9, -8, so that's where I'm going to be crossing there. I still have to go through and factor the numerator and denominator. So, well, the denominator is already good, so the nice thing with that is as we factor the numerator, I'm going to set up as we have before, and then I know I just have x plus 1 in the denominator. So I'm going to have an x in each, and I must have this thing for using negative numbers lately, so I've got a negative here, which means I've got plus and minus. Factors of 8 that differ by 2, so that'll be a 4 here and a 2 here. So then, looking at this, I have no removable discontinuity. I have nothing to worry about in that fashion. So when I take a look at the zeros of the function, okay, so zeros or x-intercepts, the x-intercepts are going to be located at, well, if x is -2, then the numerator is 0. Who cares about the denominator because the numerator is already 0? So then it's going to be at -2, 0. And then my other 0 is going to be located at 4, 0. So let's see, -1, 2 right there, and then 4 right there. And then we are going to have a vertical asymptote, and this vertical asymptote is going to be located at the line x equals -1. So just like I did before, I stored a couple lines down here. I'm going to grab that. I'm going to make it vertical. Oops, sorry. I'm going to make it a vertical line. I'm going to extend it far enough so I can see it up here. And I'm now going to move this to where -1 is. So right there. All right, so that gives me some idea of what's going on. Now I got to figure out if I have a horizontal asymptote or if I have a slant asymptote. So if I look at the degree of the numerator, so the degree of the numerator is larger than the degree of the denominator. All right, so that means I have to divide. Normally I would use long division because of just sometimes you get things down here in the denominator that might be a second degree dividing into a third degree. In this case, since it is a first degree denominator, I can go through and I can use synthetic division, which is perfectly fine. Oops, as long as I get back to using a pen. So we'll use synthetic division, which then means we're going to make our box here. And I'm going to put in the value that would make the denominator 0, so -1. I grab my coefficients again, so 1, -2, -8. Drop down the 1, and that becomes -1. That becomes -3. Multiply these two, that becomes 3. I have a remainder of 5, that's negative, but I don't really care about the remainder. What I care about is the part that's left over. I care about this because this is going to give me my slant asymptote. So we'll just call that SA for now. And then my slant asymptote is y equals x minus 3. All right, so I am going to go through and give myself a couple points from the line y equals x minus 3. So 1, 2, 3. And then with a slope of 1, I just go up 1, right 1. So we'll do that, up 1, right 1, a bunch of times. 1, 2, 3, 4. Ooh, excuse me. Sorry about that. All right, so now let's go ahead and grab our line that we have reserve down here. Time to call in the reserve here, and we will make this long enough. Drag that up here. Oh, not too bad. So almost got it right off the bat. So we'll go through, we'll add this guy in here. It looks like we have to adjust him a little bit. So we'll pull that up. That's actually pretty on. All right. So now we've got something that looks like this, and I can kind of see what's going on here. I don't have any points that are in here. I don't have any points that are down here from all of our work. I do have a point that's here, and I do have a point here and here. So let's just reinforce what we think is going to go on. So we think that we're going to have a line that comes down through here, turns, curls this way. We're going to have a line going this way, turns, curls, comes down this way. But let's make sure of it choosing a couple points. Okay, so I got enough room down here. We'll go through and pick some points just to make sure. It's always good to double check. So let's choose, I don't know, -1, -2, -3, and see what happens. So if I look up here, -3, so I'm going to do -3 squared, which is going to be 9. And then -3 times -2, so +6. And then -8. And then in my denominator, I'm going to have -2. All right, so simplify this, and I'm going to end up with +7/2, and it's negative. All right, so let's look up here. So 7/2, that's the same thing as 3.5. So we're going to go below here at x being 1, 2, 3, and then we're down here at 1, 2, 3.5. All right, so that follows the general trend of what I was thinking. We can try another value. Let's choose 5. 5 squared is going to give me 25. And then 5 times, I believe it was -2. Yep, 5 times a -2 is going to give me -10, and then -8 more. All of that is going to be divided by, so 5 plus 1, so that'll be divided by 6. So 25 minus 10 is going to be 15. 15 minus 8, so 15 minus 8 is going to be 7. Divided by 6, so 1 1/6. Okay, so if I'm out here at 5, I'm a little bit above 1, and that's about where I'm at. So you can see what's going on here. Let me go back to the full graph. I'm going to take and I'm going to do my curl this way, and then I'll make my curve. It comes up this way. And then we'll go through and make our curve. It comes to this bit because, again, we're only worried about sketching. I know that it says graph right there in the directions, but I'm more worried about, can you plot a couple points? Make sure you've got the right points. Do you include the important parts, such as what's the y-intercept? What's the x-intercept? What's the vertical asymptote? What's the slant asymptote or horizontal asymptote? What's going on in between those more than I am at precise points for your sketch? All right, so that was the end of example 3. Again, Robert Main, have a great day and enjoy.